Something very strange is happening on Jupiter every 27 minutes. Until now, researchers of the field were clueless on how to solve the biggest mystery of the gas giant. Putting the challenging puzzle together, scientists finally allowed us to understand this mysterious phenomenon and its origins. Back in the 1990s, Bernard Burke and Kenneth Franklin set up a radio astronomy array in the area just outside Washington, D.C. to collect data about different radio waves emitted by celestial bodies in space. A few weeks into their mission, they began to observe a sudden surge in radio transmissions at a particular time every night. At first, they thought it was due to some interference by elements within our Earth. But after careful observation, Burke and Franklin discovered the high radio signals were transmitted by Jupiter. Immediately, they set out to find more information that would give credence to their discovery. Eventually, they stumbled on a large amount of data accumulated over a period of 5 years. With this data, the two researchers discovered that it takes Jupiter 10 hours to rotate around its axis. So, what does this have to do with solving the mystery? The Voyager 1 and 2 spacecraft travelled past the planet in 1979, returning high-resolution images of the planet's atmosphere and its satellites. The information provided by both Voyager spacecrafts led to the discovery of Jupiter's faint and narrow ring system, which according to NASA are formed from dust particles held up by micrometeor impacts. More importantly, Voyager 1 discovered Jupiter's version of Northern Lights, the famous X-ray aurora of the planet in 1979, and made scientists crawling for the answers to solve its mystery. It turned out that the gas giant has the mightiest magnetic field in our solar system, about 20,000 times stronger than the magnetic field of Earth. If that alien magnetosphere were visible in the night sky, it would cover a region several times the size of our Moon. As such, Jupiter's auroras are much more powerful than Earth's, releasing hundreds of gigawatts, enough to briefly power all of human civilization. As NASA wrote in a statement, it was not immediately clear how the energy required to produce Jupiter's X-ray aurora is generated. They know these surprising Jovian northern and southern lights are triggered by ions crashing into Jupiter's atmosphere. But until now, scientists had no idea how the ions responsible for the X-ray light show are able to get to the atmosphere in the first place. As technology advanced, NASA began sending space probes to orbit close to the planet, gathering tons of information about Jupiter. One of the most interesting findings is that Jupiter's magnetosphere is the strongest, biggest, and most complex of its kind in the entire solar system. The region measures 12 million miles from one edge to the other, or about 15 times the width of the Sun, and is home to a 40-year-old mystery that has been solved just recently. It was just like pump, a burst of light, then wait 27 minutes, chill out, and then another burst of light, and wait 27 minutes, chill out, and then another burst of light. William Dunn and his colleagues were confused about the happening that turned out to be in relation with Jupiter's mysterious auroras. To understand how they were able to wrap up the case, we need to tell a few words about a particular spacecraft that is orbiting Jupiter at this very moment. On July 4, 2016, Juno, a solar-powered spacecraft launched by NASA in 2011, pierced below Jupiter's dense clouds. Since then, the space probe has gathered more than 3 terabytes of scientific data while orbiting the planet once every 53 days. Some of Juno's most significant discoveries include a close-up picture of Jupiter's North Pole and confirmation of a cluster of Earth-sized storms. The spacecraft's magnetometer investigation instrument also showed the Great Red Spot in 3D. Furthermore, the Juno cam cleared the confusion about the existence of water on the planet, while also recording higher frequency lightning. But more importantly, data gathered by the Juno spacecraft helped scientists to solve the mystery about Jupiter's X-ray auroras that scientists have been struggling with. On Earth, the aurora is a product of a natural process by which electrically charged particles or ions eject from the Sun, collide with oxygen and nitrogen atoms in Earth's atmosphere. Auroras are the process that create them and can be found throughout our solar system. Scientists know of auroras on 7 of our Sun's planets. Some are visible to the human eye, others require specialized telescopes to be seen. Jupiter is the only one of the 4 giant planets with an aurora that has been found to emit X-rays. But the most interesting fact about Jupiter's aurora is that, unlike the Earth's, they are always there. Astronomers say that this is because the planet grabs charged particles from its surroundings, including those being spilled out by its moon, Io. But they couldn't really explain how the energy required to produce it was generated until scientists decided to combine data from the Juno spacecraft and the European Space Agency-owned XMM Newton telescope. After the observation period that lasted 26 hours, scientists confirmed that Jupiter's X-ray auroras pulsates every 27 minutes, a mind-blowing discovery that caught scientists by surprise. It's kind of beautiful because you see this chain of events that lead up to the burst of light from the X-rays. Jupiter does this really weird thing where it pulses with a regular beat like clockwork, Dunn said. You can actually set your watch to it. Now, for the first time, scientists have seen the ions surfing electromagnetic waves in Jupiter's magnetic field down into the atmosphere. However, Jupiter's X-ray auroras are inconsistent with this picture. They exist poleward of the main aurora belt, pulsate regularly, and can sometimes be different at the North Pole from the South Pole. These are typical features of a closed magnetic field, where the magnetic field line exits the planet at one pole and reconnects with the planet at the other. According to updated information provided by the Hubble Space Telescope, Jupiter's X-ray auroras are 100 times bigger and stronger than those on Earth. The rapid rotation, the really strong magnetic field, and all of this volcanic stuff that Io is pumping out just like swells and blows Jupiter's magnetosphere to this crazy size. It's a huge structure and there are so many crazy things going on. The combination of different observations led scientists to wrap up the case and solve one of the biggest mysteries Jupiter had for us. This amazingly weird 27-meter heartbeat starts with a little vibration of a magnetic field in the chain of events. Then this vibration triggers EMIC waves, also known as electromagnetic ion cyclotron waves in the magnetosphere. Those waves carry particles that surf their way down the atmosphere, where they get dumped. At that very moment those particles hit the atmosphere of the planet, they produced X-rays and triggered the constant aurora of the gas giant. Scientists say that the aurora of the celestial body tells us what processes are going on in that magnetic field and in the space environment around the planet. And as we already know, magnetic fields are crucial to sustain life on any planet. In our case, Earth's strong magnetic field helps to sustain liquid water on the surface, making it possible for life to thrive. Studying Jupiter's auroras isn't over yet. European Space Agency's Jupiter Icy Moons Explorer, aka JUICE, will arrive at the planet by 2029. This spacecraft will study its atmosphere and magnetosphere and the effect of Jupiter's 4 largest moons on its auroras.